At 6 a.m. local time over Tambov skies, a full-scale assault commenced. 43 Ukrainian unmanned aerial vehicles screamed toward the Progress missile plant, the most heavily guarded airspace in western Russia. Yet somewhere west of the facility, buried beneath a rail spur feeding every supply line to the Crimean peninsula, something had lain in wait for weeks. Russian crews had no idea they were about to win every engagement that morning, and that was precisely what Ukraine intended. Before diving deeper, comment number 2 if you support Ukraine, number 3 if you support Russia, and number 4 if you love peace.
The first contact signals appeared on radar scopes at 6:04 a.m., followed by 6 more, fanning out across the northern approach in a formation designed to light up every radar display in the corridor simultaneously. These were UJ-22 drones with an 800-kilometer range, a radar cross-section roughly the size of a large bird, and a unit cost of $30,000. Cheap, expendable, and about to become the single biggest economic headache for Russia's air defense network. The Zio Position Indicator, PPI scope, on the Panzer system, the familiar sweeping green radar trace seen in every submarine movie, remained clean at first. 4 minutes later, the northern arc erupted with contacts, 8 targets, then 12. The battery commander immediately hit the combat net, dividing sectors among neighboring crews and attempting to coordinate so no 2 batteries wasted missiles on the same UAV, or worse, both assumed the other had already engaged it. Deciding which target to engage and who should hold fire turned into a coordination nightmare with every new blip. By 6:04 a.m., the number of targets already exceeded the number of assigned batteries. Zu-23-2 anti-aircraft gun crews spotted them first. At treetop height, radar struggled against ground clutter, but the gunners' naked eyes did not. They heard the high-pitched whine, like chainsaws echoing across frozen fields, before they saw the shapes. Gray airframes, barely larger than a dining table, skimming the treetops at 125 miles per hour. At that speed and altitude, each drone stayed visible for only about 5 seconds before passing overhead and becoming someone else's problem. Gunners tracked with mechanical sights and muscle memory, while the Panzer radar still wrestled to classify targets amid ground returns. The Panzer S-1 system, shown here, is Russia's answer to drone swarms, a mobile platform carrying 48 miniature TKB-1055 missiles at roughly $170,000 apiece. Think of it as the most expensive fly swatter ever built. In seconds, the 92 N6E acquisition radar, the spinning dish atop the vehicle, sweeps the sky on a 3-second cycle, redrawing everything within 18 miles. Once it tags a target, control passes to the lower fixed-array 10ES-1E fire control radar, which locks with millimeter precision and computes intercept geometry. From initial detection to missile launch took 14 seconds, faster than most people can parallel park, but only under ideal conditions. The incoming UJ-22s flew at treetop level, blending their radar returns with ground clutter from buildings, trees, and terrain features, all reflecting at the same frequency. At those altitudes, effective detection range for the acquisition radar dropped from 18 miles to about 7.5 miles, and the fire control array had to extract the UAV's signature from the noise floor beneath it. It was like trying to hear someone whisper your name in a packed restaurant. At 6:05 a.m., the first TKB-1055 left the rail, crossed 3 kilometers of airspace, and turned a $30,000 Ukrainian UAV into fragments. A second UJ-22 went down. A third followed 12 seconds later. The system was doing exactly what Moscow had spent billions to make it do. The only problem, Russia was buying a Porsche to swat a go-kart. When the economics are that lopsided, the go-kart side does not need to win any single engagement. It just needs to keep showing up. From 48 missiles loaded at 6 a.m., only 31 remained by 6:10 a.m.,
and just 19 by 6:15 a.m. UJ-22s now approached from multiple vectors, north, northeast, northwest, spaced so each battery had to engage singly, burning 6 seconds per kill cycle. Detect, classify, decide, fire, repeat, while ammunition counters ticked downward like a fight clock. One northern Panzer locked 2 UJ-22s simultaneously, fired on the closer one, and watched the second sail past untouched toward the plant. The eastern battery was down to 8 rounds with 3 targets of its own. The air defense corridor was hemorrhaging missiles faster than it could kill drones, and every crew on the net knew it. They were falling straight into Ukraine's trap. 200 kilometers east, a fuel train was scheduled to pass through Kochatovka 2 later that afternoon. Air defense crews did not know this, but they were not merely guarding a factory. They were guarding the only thing preventing that buried phone beneath the rails from ringing. Reloading was not a viable option. A panzer cannot swap magazines in the field like a rifleman changing mags. It requires a dedicated Kamaz reload truck, a 4-man crew, and Rufus-Sleddy Linux with the entire system offline. Radar dark, launchers exposed, vehicle defenseless. Even with resupply parked right behind, the moment the crew began reloading, they became a 65-ton missile fuel sitting duck. Going offline for 20 minutes amid an ongoing swarm was effectively going offline permanently. As UAVs kept pouring in, one question kept surfacing in Russian minds: why? They did not realize the drones did not need to survive, they needed to be seen. Their radar cross-section had been tuned to sit squarely in the Panzer detection envelope, clear enough to trigger auto-lock, slow enough to force a full engagement cycle. That was not a design flaw, it was the design intent. A stealthier UAV might slip through, but it would not bleed magazines dry en route. While Panzer systems stayed busy firing, Zu-23-2 truck-mounted guns rushed to plug gaps. The twin 23mm autocannons delivered 800 rounds per minute and remained effective out to about 1.5 miles. Engagement geometry was brutal. A UJ-22 at treetop height, traveling 125 miles per hour, gave gunners roughly a 4-second firing window. Leading such a target was like trying to shoot a flying trash bag on the freeway. One gun scored a direct hit and shredded its drone. Another burned 40 seconds of continuous fire to clip a wing, leaving the barrel glowing red. Those barrels were rated for about 600 sustained rounds before steel began to deform, and 40 seconds of full auto fire exceeded that limit within the first 15 seconds. After 2 engagements, the gun either wandered off target or needed cooldown to prevent cook-off. By 6:20 a.m., 12 UJ-22s had been downed, at a cost of over $2 million in ammunition. Ukraine's total expenditure, $360,000. Every tactical engagement was textbook. Strategically, it was a disaster.
Then at 6:25 a.m., fresh signals punched through the UJ-22 screen. Faster, higher, heavier returns. These were not decoys powered by lawnmower engines. These were AN-196 Luty UAVs, 1,000-kilometer range, 165-pound warhead, enough to level an entire factory floor. And here was the detail that turned this awful morning into a masterpiece of operational planning. The Luty had not launched simultaneously with the decoys. Ukraine had released them hours earlier from deep rear airfields. The slower decoys launched later from much closer staging areas. Shorter distance trumped higher speed, so the decoys arrived first. The faster Luty, forced to cover hundreds more kilometers, trailed by 20 minutes, flying through a now empty corridor whose defenses the decoys had already exhausted. That synchronization across hundreds of kilometers of airspace was no accident. Someone had calculated exactly how many UJ-22s it would take to deplete Panzer magazines, added a safety margin, and built the entire operation around the ammunition counter hitting zero at the precise moment.
15 kilometers out, the first UT closed at 217 miles per hour. 12 kilometers, a second appeared, hugging terrain from the southwest. 10 kilometers, a third. Pantsir crews watched them come and ran the math no classroom ever teaches. One crew locked a UT for 6 seconds without firing, 3 missiles left. Another UT trailed it, and a third closed from the southwest. They let the first one pass, watching 165 pounds of high explosive glide toward the plant with nothing but air between it and the target. They let it go because the alternative was worse. Fire the last 3 rounds and sit helpless while the rest of the morning unfolded around them. Down the corridor, another crew faced the same equation. 2 missiles for 3 targets. They fired once, scored, watched the second UT sail past, and never even acquired the third. Every battery made the same impossible choice. Shoot and go dry, or hold and watch a warhead fly over your position toward what you were tasked to protect.
At 6:35 a.m., one UT, GPS locked and flight path stable, suddenly began drifting. Not from battle damage or malfunction. Its onboard coordinates slid 3 degrees, then 10. Another UT from a different vector drifted the same way. A third stopped responding to its flight plan entirely and plowed into a field at 125 miles per hour. No shots fired, no intercepts, no sound at all. Just targets drifting off scopes and vanishing one by one. Something out there used no ammunition, emitted no radar signature, and had been active before the first UJ-22 ever crossed the border. The R-330 Zhitel system shown here looks unremarkable. A Ural truck towing an antenna-laden trailer parked near the plant since before dawn. No missiles, no guns, no visible moving parts. Yet that truck inflicted more damage on Ukraine's strike package with 1 tank of diesel than every Panzer in the corridor managed with a full magazine load. Zhitel is a broadband jammer that essentially strangles GPS signals. A GPS signal originates from a satellite 12,400 miles away and arrives at the UAV antenna with roughly 20 watts of power, comparable to a car headlight seen from the opposite side of the planet. That signal carries timing data the UAV needs to compute precise position, and it must arrive with nanosecond accuracy, or the math collapses. Zhitel does not decode or spoof the signal. It simply outshouts everything from 100 MHz to 2 GHz with broadband noise across an 18-mile radius. Every navigation band inside that bubble, GPS, GLONASS, Galileo, vanishes beneath a wall of static. It is less sniper rifle and more fire hose. Crucially, a UAV inside the bubble does not merely lose signal, it receives a lying signal, phantom coordinates unrelated to the ground below, fed into an onboard computer with no way to know it is being deceived.
The effect was not limited to UAVs. Cellular service around Machurinsk had been spotty for months. 88,000 civilians blamed their carrier without realizing a phone buried 5 kilometers west under the rails suffered the same fate courtesy of that truck. Every UAV that survived Panzer and Flak flew straight into the bubble and became disoriented. Inside each drone, the GPS receiver began ingesting microsecond shifted timing data. Tiny errors compounded into massive position jumps. Drift 50 meters east, sudden 200-meter leap north, then back again.
The autopilot chased ghost coordinates, overcorrecting and undercorrecting, each adjustment pulling it farther from true course. The UAV never knew it was lost. Its instruments insisted everything was fine. That is why jamming is far deadlier than missiles. It does not break the computer. It convinces the computer everything is normal, while the platform flies into the ground. One Lutyi, the heavy hitter Ukraine spent the entire morning shielding, drifted 11 degrees off track, self-corrected toward a non-existent point, and slammed into trees 6 kilometers from any valuable target. A $4 million strike drone reduced to scrap by a truck burning 40 liters of diesel per hour.
Inside the Zhitel station, operators watched the jamming dome perform flawlessly for 50 minutes. Every target entering the bubble drifted, none escaped. The system operated exactly as designed. But at 6:45 a.m., certain Luti held rock-solid course. No drift, no deviation. Zhitel was broadcasting at full power across every band, yet these UAVs showed no reaction. On the jammer's monitors, operators could see maximum output, but the targets simply did not care. They held steady westward, straight toward the station. Something they had never encountered before was inbound, and they had no weapon to answer it. Each of those UAVs carried a Skynode S flight computer. And here was where Russia's entire defensive concept collapsed. Most UAVs navigate the way you use Google Maps, follow GPS waypoints step by step, and hope. Lose signal and you are lost. Skynode does not work that way. It navigates visually, matching the ground below to real-time satellite imagery, reading roads, rivers, and tree lines the way a pilot reads landmarks through a cockpit window. Before launch, the UAV's memory is loaded with a satellite image map of the entire route. In flight, the downward-facing camera compares what it sees with what it expects to see, computing position from visual features without external signals. Inertial measurement units, gyroscopes, and accelerometers dead reckon beneath, corrected by the camera every few seconds. You cannot jam a camera. You cannot drown out a gyroscope. These UAVs flew through 30 kilometers of broadband jamming the way a deaf person walks through a rock concert. Russia's entire electronic warfare doctrine rested on the assumption that UAVs need satellites to see. Skynode does not.
And they were not heading for the plant. On radar screens, their tracks converged on a 0.5 kilometers west, a completely different target. 8 kilometers away, the nearest pantsir was already dry. Flak trucks 10 kilometers east would take 8 minutes on a trip that would end in 90 seconds. 6 kilometers, 5 kilometers, one single target, holding perfect course through 30 kilometers of jamming. No drift, no wonder. Zhitel crews had just watched 30 UAVs go lost inside their noise bubble. Yet these drones flew straight through it, like free Wi-Fi. At 3 kilometers, the Zhitel station had been radiating its own position across the electromagnetic spectrum for 55 minutes.
Ukraine had preloaded those coordinates before the UAVs ever launched. The agents who buried that phone had finished their part weeks earlier. Now, the only thing between them and a completed circuit was a truck full of antennas. At 2 kilometers, the Skynode camera locked the truck chassis, matching it precisely to reference imagery. At that range, the flight computer shifted from terrain matching to specific target recognition. The truck, the trailer, the antenna arrays. The most powerful air defense asset in the Tambov corridor, with a 30-kilometer reach, had no weapon to fight back. With a 165-pound warhead, impact was 4 seconds away.
At 6:58 a.m., the Zhitel system disintegrated. 165 pounds of explosive slammed into the Ural chassis and trailer. Antenna arrays collapsed in the blast, and 30 kilometers of broadband jamming vanished across every frequency, as if someone flipped a switch. GPS signals snapped back instantly, GLONASS locked. Navigation tracks across the corridor straightened like compass needles swinging north. The plant now lay wide open, Panzer batteries dry, jamming gone. A follow-on strike would have hit unobstructed, but no further UAVs arrived.
Russian crews sat in their vehicles and at their guns for what felt like an eternity, wondering where the Ukrainians had gone.
The surviving drones had flown straight past the plant. After 30 minutes of inactivity, they stood down, jubilant, believing they had won. In reality, they had executed Ukraine's script to the letter, and they would not be smiling when that day ended, because somewhere beneath a rail spur, a phone had just acquired its first signal bar in months, and a fuel train was now en route. At 3:30 p.m. that afternoon, the fuel train rolled into Kochatovka 2, the classification yard 5 kilometers west of the plant, where the main Moscow-Voronezh-Rostov line narrows to a single-track choke point. Every supply shipment for Crimea and the southern front must squeeze through here. When it halts, 3 forward divisions stop receiving fuel. The train consisted of 16 tank cars, 11 gasoline and 5 compressed gas. Buried in the ballast beneath the rails sat a device that had waited there for weeks, a wired mobile phone connected to a detonator, invisible from the surface, waiting for one thing, a signal bar. A successful connection to the nearest cell tower was all a phone-triggered explosive device required, not a call that must be answered, just a strong enough handshake to complete the circuit.
For months it could not connect. Cellular service around Mucherinks had been abysmal ever since Zhitel set up station. Dropped calls and messages stuck in outbox queues were complaints 88,000 locals blamed on the carrier and then forgot. But the carrier was never the issue. Zhitel jamming made no distinction between uniforms. The noise wall from 100 MHz to 2 GHz buried everything. GPS, GLONASS, and every cellular band a phone needs to reach a tower, including GSM 900, GSM 1800, and LTE. All collapsed inside the bubble, including the phone under the rails at Kochatovka 2. At 6:58 a.m. that morning, when Zhitel was destroyed, the bubble burst. Not only did GPS return, every cellular band across 30 kilometers reopened for the first time in months. At 3:34 p.m., someone placed a call. The rails split beneath the fourth car, and the train began jackknifing. Cars derailed in sequence, couplers tore apart, and the entire consist folded at 37 miles an hour. Tank shells ruptured on impact. 11 gasoline cars spilled into the air. A fireball soared 1,000 feet above Michonensk, smoke spreading kilometers across the countryside. Heat was so intense it drove firefighters back before containment could begin. The single-track choke point feeding Crimea and the southern front was severed, and resupply to 3 forward divisions halted. The entire operation, 43 UAVs, 58 minutes, millions of dollars, existed solely to deliver one cell signal bar to a device under the rails. Comment number 2 if you support Ukraine, number 3 if you support Russia, and number 4 if you love peace.